do want to report those out if you see them. And the only trouble we have is when we send students to clinicals, occasionally, for whatever reason, it's like you're either seeing them all the time or you go like 3 or 4 weeks and you don't see them, okay? But hopefully when you're at clinicals, they will get a specimen that has those. But I think if you look at them on YouTube, you'll see all you need to see, because you'll see them swimming around. They're pretty easy to identify. Now, there are other parasites that you can see. We will talk about trichomonas when you take parasitology toward the end of micro, and you'll see like the picture on page 120 where you'll see one that's stained. I'm talking about having to recognize one just in a regular urine sediment with no stain, being able to tell what they are. There are some other parasites and parasite eggs you'll find in urine sediment, but they are very rare. There's pinworms. There's a name for that called Enterobius vermicularis. That's that one that they can take a piece of Scotch tape in the anal region and pull off those eggs, called pinworms. There's another one called schistosoma that you can see, but those are rare. As far as your test, if I ask you to name a parasite that's in the urine, I want to hear Trichomonas vaginalis, because you'll see that out of 1,000 of them, 990 of them will be Trichomonas, okay? So that's the one I want you to remember. Spermatozoa on page 120. Remember that urine is toxic to sperm. So I know some movies and stuff, you'll see the little sperm swimming and all that type of stuff. In a urine specimen, you will see sperm occasionally. They'll usually have a little tapered head and a little, you know, kind of like that. But they will not be mobile in a urine specimen. They will be dead because urine is toxic to sperm. So you will see them. Some places don't even want you to report them if you see them, okay? Now, use common sense there. If you're doing a wet prep back in micro, it has to do with somebody that's came into the ER and they're thinking, you know, possible some sort of a rape or something like that. Well, yeah, they want to know. But if you're working at your urinalysis lab, you know, you will see them from time to time. But again, they're usually going to be dead still because they're dead.
How long do they usually show up in your urine after the fact?
How long?
Just when you first void, or and then it's over with?
Yep. I mean, you wouldn't even see it at all, but remember, you're spinning down the urine, so anything that's in that urine, you're concentrating it to that sediment at the bottom. And I mean, I'm just saying, you will see those. I mean,
I've seen one in the one at Fordyce, but it was an older man. He had something going on. So
well, you'll see them, but most of the time, again, depending on the policy where you work at, they may just have a standing protocol that says, unless we ask, don't even tell that you're seeing an occasional sperm or whatever. Mucus on page 120 in the right-hand column. Mucus, you have to note if you see it, it's not that it's a contaminant, but a lot of times mucus is just going to be like real fine, like stringy lines. Just think of like mucus in it. Sometimes it just obstructs your view. Sometimes mucus can be heavy. Sometimes it's not. I don't like the picture that your book has, but we'll go with it. I've got better pictures on Kodachrome slides on page 121, picture A. That's supposed to represent a mucus strand. I know it does, it does, but mucus usually it looks like a hazy skyline, like it's just hazy little streams and stuff. But one of the things you do need to realize is that sometimes, the reason I say that is, like, pretend that's mucus. We're going to talk in a little bit about what a hyaline cast looks like. And a hyaline cast, okay, you see how you could get this confused with this? That's one of the things that you got to watch out for, is that you don't call mucus strands a hyaline cast. We're going to talk about hyaline cast here in just a minute, okay? Because they're made out of the same type of protein. There's a protein that makes up mucus and certain casts, and it's called a uromodulin. And I'll tell you where that's at in the book. No, it's right there under mucus. Third line down under mucus. It mentions uromodulin.
So it makes up mucus and then some casts, not all of them, you said.
Well, the cast matrix, the matrix of a cast is made up of uromodulin, which is a type of protein.
Okay.
Okay, on page 121, that paragraph just above the word cast, Says mucus is more frequently present in female urine specimens. It has no clinical significance when present in either female or male urine. Okay, so now let's talk about casts. On page 121, it says casts are the only elements found in the urinary sediment that are unique to the kidney. They are formed within the lumens of the distal convoluted tubules and the collecting ducts, providing a microscopic view of conditions within the nephron. All right, so I'm going to draw something and kind of explain something. You guys follow with me real quick. Okay, here's the nephron. Okay, right here is where they're talking about. Okay, kind of the distal convoluted tubule going down into the collecting duct. Y'all with me? Okay, I want you to think about if your urine flow is kind of stagnant. Like think about you're not getting good blood flow, which means your glomerular filtrate is not running through at a constant rate. So sometimes think of like an interruption in the flow of your glomerular filtrate, and you have certain proteins and things that just kind of get stuck here for a minute. And think about kind of a precipitate forming, like the matrix of a precipitate, and then all of a sudden you get flow going again, and so this whole thing breaks off and goes down. See what I mean? It's like a large chunk of protein formed right there because the urine got kind of stagnated for a second. And so it breaks off, and then when we see it in urine, what was right here ends up appearing as looking like this in the urine. In other words, it kind of represents how the tubule looks right there. All right? There's different types of cast. I think the question that they'll normally ask you about cast is what's the protein that makes up the cast matrix called, and it's uromodulin. It used to be called tan horsefall protein, and they've changed it on me. So I gotta make sure I've got that right on there. So we gotta talk about all the different types of cast. Okay, on page 122 under cast composition and formation, the very first sentence says the major constituent of cast is uromodulin.
Question.
Yep.
That uromodulin, that's the same uromodulin that has to do with mucus.
Yes. Yep.
Oh my gosh.
Okay, lots of reading because I think the book goes too far talking about cast. So I'm just going to basically tell you what I want you to know. The different types of cast that I want you to read about. The first one and the most common type of cast that there is called a hyaline cast. It is very, very light. It's going to appear like this. Okay, and you have to have the microscope in real good focus in order to see this. I would never call a cast when I worked unless I could honestly see the ends of the cast come together. This is the protein matrix. You won't see anything inside it, okay? It's just a protein matrix outline. It looks like, I don't know what you call it, cold or big hot dog or whatever you want to call it, all right? It's one of the largest things that you'll see in the urine sediment, okay? But this is called hyaline. Hope I'm spelling it right. Hyaline cast. The next one that they have, and they think that this is caused from cellular breakdown, is you've got a cast that's called a granular cast. It'll have little granules in it. Granular. And they claim that these granules may be the disintegration of what was a cellular cast. Sometimes in that little matrix that I told you that forms at the distal convoluted tubule, sometimes cells get trapped in that. And so when that cast breaks off into the urine, you may see they have casts called red blood cell cast, they have white blood cell cast, I think they have epithelial cell cast, they even have fatty cast that have lipid contents in it. Or guess what, if you look at it under polarized light, you'll see those oval fat bodies everywhere. Remember those, not oval fat bodies, I said that wrong, the Maltese cross, okay? So you got hyaline cast, you got granular cast. Another type of cast that you got is called a broad cast. These are the ones you don't want to see, okay? These represent your broad, and your book is gonna talk about another one called waxy cast. You don't wanna see these because these represent kind of extreme stagnant urine. In other words, that thing was at that distal convoluted tubule quite a while before it broke off and went into the urine, okay? And I think the waxy cast, sometimes they'll show them where they look like this. Okay, this one, the broad cast, the waxy cast. I just want you to think of these as bad, bad. All right, bad, bad. This is actually normal. You can see this in somebody that's just been exercising. It'll tell you that in your book. Somebody that's just came from some sort of strenuous exercise or something. You can actually see a Highland cast in the urine. I think they say 0 to 2 per low power field is considered normal. This is the one that I was telling you about this is the one that I was telling you about that you view these under low power, okay? Because they're so big, you don't want to view those under high power. That's me. I just don't have it on silent.
And I was like,
I'm
Was the
waiting,
microphone projected back
I'm
here?
waiting on an important phone call. I knew it was on, but I had to, that's not it though.
The microphone
no, you're good, we
projected
just trying to make sure what it looks like.
No, it's me. Okay, so Highland, granular, broad, and waxy. But again, when you read over this in your book, I'm leaving out a lot of stuff. Again, all those cellular casts and things, I think they even have bacterial casts where they're loaded with bacteria in your book. So I want you to know the 4 types. I want you to know that these are normal. You're gonna see these a lot. You'll see these at clinicals. I have never seen one of these, ever, okay? But if you do see one, it's not good. It's usually somebody that has severe kidney trouble. Most of the time you see them in books. I've seen a lot of these granular casts. You'll see those, and they even break it down. You have what's called finely granular cast and coarsely granular cast. So if I asked you out of the cast that I just told you about, even though I didn't list it on there, if I said this cast is capable of polarizing light,
It's gonna be that, the fatty one.
fatty cast, okay.
Cause it has a cross.
Now, I will direct you on page 124, the right-hand column. Make sure you have this marked in your book, under white blood cell cast on page 124. In the right-hand column on page 124, the appearance of white blood cell cast in the urine signifies infection or inflammation within the nephron. They are most frequently associated with pyelonephritis, that is an upper urinary tract infection, and are a primary marker for distinguishing pyelonephritis from cystitis. Cystitis is a bladder infection, okay? Pyelonephritis is when you're going above that, and you're getting into the ureters and going up to the kidneys. Okay, everybody with me on that? So, for whatever reason, the book always talks about that. They love to ask that question at student bowl. How do you differentiate pyelonephritis from cystitis? And it's that you will see white blood cell cast in the urine sediment. So in other words, you'll see one of these that'll it'll have white blood cells trapped in it. With me? Like even if you just see 4 or 5 of them, that would be considered a white blood cell cast. All right. Let's go to the urinary crystals. Page 128. Page 128, under urinary crystals in the right-hand column, it says crystals frequently found in the urine are rarely of clinical significance. So even though we're going to talk about all these little pretty crystals and how they look neat, and you'll see them in the urine and know what they are, there's only so many of them that are truly called pathologic, to where it's of primary significance that the physician know about those. right? All right, crystal formation on page 129. Basically, it has to do with the pH of the urine. Read over that. The temperature, some things actually precipitate out from the crystal. Because of that, under crystal formation, go to the last paragraph under that section, and it says a valuable aid in the identification of crystals is the pH of the specimen, because this determines the type of chemicals precipitated. So as I present this to you guys and talk about it, when you study it, I want you to study it as these are acidic crystals, these are alkaline crystals, and these are pathologic crystals. So I'm gonna draw pictures on the board because they love to show you pictures on your registry and identify those crystals. But I just want you to understand, if I'm talking about an acidic crystal, except for a couple of extreme rare cases, there are only certain crystals that will be in an acidic urine. Like if I tell you a triple phosphate crystal is in acidic urine, I want you to tell me back, that can't happen. Because triple phosphate is an alkaline crystal, you would never see it in acidic urine, okay? So the first ones we're gonna talk about are the acidic crystals. And always, also remember, for the most part, these crystals that we're gonna talk about are completely normal. I'm on page 131 in the left-hand column, normal crystals seen in acidic urine. It says the most common crystals seen in acidic urine are the urates, consisting of amorphous urates. There's a crystal called uric acid, and there's also one called sodium urates, okay? So, uric acid is a crystal that's seen in acidic urine. You've heard of it before because I told you it is seen in uric acid, gout, okay? Uric acid is a crystal that if I see a crystal that I even remotely think is a uric acid crystal in a urine sediment, the first thing I'm gonna do is I'm gonna look at my urinalysis result and look at the pH of the urine. Because that pH of the urine is gonna be like 4.5 or 5. It's gonna be very acidic, okay? There's no way to tell you what uric acid crystals look like because they come in so many different forms. Look at page 132. Look at the very bottom box, figure 6-76. That is one form of what uric acid will look like when it's not polarized. See the two boxes beside it with all the pretty colors? That's uric acid under polarized light. So I can't tell you exactly what it looks like, other than it looks squarish. It can come in all different shapes and sizes. But if that urine is acidic, and you put the polarizing lenses and you see little boxes that are looking blue and green and pink and all that type of stuff, it can pretty much only be uric acid. Okay, it comes in different shapes. Another one is called amorphous urates. Remember, that is usually a contaminant from a refrigerated specimen. Okay, amorphous urates. That's another crystal that you can see in acidic urine. All right, another one that can be in acidic urine, or it can be in neutral urine, is called calcium oxalate. Now, I want to show you what that looks like. It's not in your reading. I don't think they've even got calcium oxalate. I don't even know if they have it in acidic crystal anymore. This is the most, in my opinion, from all the urines I've done, it's the most common crystal you'll ever see, okay? You see them all the time. They look just like this.
Yeah, there's one on 133.
Does it say acidic urine or does it say neutral?
It says
It says dihydrate calcium
All right.
in the chart it says acid/neutral, and then in parentheses it says alkaline. Yeah.
I want you to think of this as an acidic or a neutral crystal. If somebody's trying to explain it to you in a test question or on your registry, they're gonna say that it's shaped like an envelope. You see an envelope there, kinda?
Yes.
Okay?
Yeah.
They can be small, they can be big, but this is a calcium oxalate crystal. Now what Wendy was referring to is these crystals. It's the only crystal I know of that actually has two very distinct forms. It's got the envelope form, and then there's another one. This is called the dehydrate form, and then there's a monohydrate form that they try to present as like dumbbell shaped. It'll either look like that or look like that. This is the dehydrate form of calcium oxalate, This is the monohydrate form of calcium oxalate. You will see this out of 100 times, you'll see that 95% of the time, maybe this, maybe 5% of the time. All right. Now, since we're on it, I'm gonna draw this dehydrate. This is monohydrate. The reason this is so important, if you were to be looking at a urine specimen, especially on a younger child, somebody that's maybe, I don't know, 5 or 6, 3, 4, 5 or 6, if you see massive amounts of this in a urine specimen sediment, there's a good chance that that child has swallowed ethylene glycol.
Oh.
Okay, because any child that drinks radiator fluid, because of its sweet taste, these will be everywhere in the urine sediment, the monohydrate form. I've never seen it. I mean, I've never seen that, but I'm just telling you that if you were to see these type of crystals everywhere, you need to make sure and report that out. You know, antifreeze has a sweet taste to it. They tell you to keep that away from kids.
Oh, well, she just-
Kids, animals, everything needs to be kept away from
You know,
everything.
people feed other people's animals and stuff.
Yeah, kill them.
Well, she's been like 2.5 months long, so she didn't come down.
People are terrible.
That's what happened to my parents had
All that
a
stuff I
breeding
told you
pair
about
of
calcium oxalate crystals is on
German
page
shepherds,
133.
like long-haired German
In the
shepherds.
left-hand column about the two different
Neighbors
types,
killed them.
the
They
dehydrated
didn't even
form
bark. They
versus
just killed their dog.
monohydrate form. And another thing that you need to know about calcium oxalate is most renal calculi, I think Haley said this the other day, most renal calculi are made up of calcium oxalate. That's what most kidney stones are made up of, is calcium oxalate. And it tells you that on page 133, left-hand column, go down like to the last sentence. It says the majority of renal calculi are composed of calcium oxalate. There's a case study at the back of this chapter that talks about ethylene glycol poisoning. Read it, know it. All right, normal crystals seen in alkaline urine. I'm on page 133, right-hand column, last section there. It says phosphates represent the majority of the crystals seen in alkaline urine and include amorphous phosphate, again, refrigeration, triple phosphate, and calcium phosphate. So be able to give me those examples, but I'm gonna show you, or I'm gonna draw a picture on the board of the most common alkaline crystal you will ever see in a urine specimen. It's called triple phosphate, and they are shaped like this. They call them a coffin lid appearance. Everybody with me? A coffin lid appearance, triple phosphate. If I see this crystal in a urine specimen, the first thing I do is I look at the pH of the urine. I would never say I see a triple phosphate crystal if the urine pH is 4.5. You see what I'm saying? It's gonna be above 7. Triple phosphate. Sometimes these are really, really big. Sometimes they can be smaller. And somebody showed me a picture of one. Where were pictures that got them on?
6-85.
Yeah, 6-85. That's a picture of one. There's also a picture of one on page 135. I don't know if it says it in the picture, but on page 135, look at the picture in the middle of the page.
Oh, yeah.
Now, even though this kind of goes against what I'm telling you, there's a calcium oxalate crystal in that picture. There's also a triple phosphate crystal.
Oh, there's this one.
Which tells me it's
There's that
not.
one.
And I see the triple
Is that
phosphate crystal in it. And I see the little
the
X, the
thing?
calcium oxalate crystal.
The yeast.
We're gonna talk about ammonium biurate. Ammonium biurate, since I'm drawing pictures. Okay, this is triple phos. Again, there's better pictures in your book, triple phos. These are the most common that you will always see. I mean, a lot. This is calcium oxalate. I'm not even gonna draw the other form because this is the one you'll see most of the time. There's another one that is seen in alkaline urine that your book talks about. It's called ammonium biurate. And I've always called this one the thorny apple crystal. Okay? I'm just drawing what looks like a thorny apple. This one is normally found in older specimens. It's like a specimen that's been sitting at room temperature for a long time. The urine becomes alkaline, and there's a crystal called ammonium biurate. And if you ever hear it described, they will describe it as a thorny apple appearance. Ammonium biurate. Have you got a picture of one of those?
Yeah.
Does it look like a thorny apple?
Yeah, I guess you could say that.
You got a good picture on page 135 in your book, figure 6-88 shows you a picture of ammonium biurate.
That was
See them?
that one.
They look like little monsters.
Thorny apple. Okay, so again, this is a common crystal, and uric acid. But I can't really draw uric acid because uric acid, I've seen them in shapes that look like footballs. I've seen them in squares, and I've seen them like this, okay? These are all shapes that uric acid can come in, but if I think I see uric acid, I'm gonna look at my polarizing lenses and make those pretty colors flare up.
And that's the dead
And it'll be in acidic urine. Pretty much everything that we talked about up to this point are crystals that they don't consider pathologic because they can be found in normal urines, all right? But you do need to know the pathologic crystals. Abnormal urine crystals, page 135, right-hand column. It says abnormal urine crystals are found usually in acidic urine or rarely in neutral urine. So the examples that I need to know of the abnormal or the pathogenic are going to be cysteine. I call that six-sided cysteine. I'll draw you a picture of one. Cholesterol crystals and crystals associated with liver disease. That's going to be leucine and tyrosine. All right, a cholesterol crystal. There may be a picture in your book, but you always want to look for the notched edge. It'll look like this. Something like that. That's cholesterol. You don't want to see that in urine.
Yeah.
Okay?
That's
They
cool.
have notched
They
edges.
look like they're,
All I can tell you is think of squares
Stacked up on top
of
each other,
squares, and
yeah.
There's usually a notched edge somewhere in it.
yeah, these are rainbow. They're amazing.
What about a rainbow?
They have
Here, come, because that's
Colors.
a picture in the book that they have.
Yeah,
of
they
those.
polarize light.
Yeah.
Right on.
Cholesterol will polarize light.
I feel bad for
But
them.
they look
All right,
the same
so
shade
this is
different.
cholesterol. That's a pathologic crystal you should not see. Cysteine, I call it to me it looks like a stop sign, but it's got 6 sides to it. I'll probably draw it wrong, but it's something like this.
Okay. Yep.
Okay?
Yep.
I call it 6-sided cysteine. I just think of a stop sign, but I think a stop sign truly has 6 sides. But anyway, so it looks kind of like this, okay? Cysteine, that's an amino acid disorder, or cystinuria, okay? Where you could possibly see cysteine crystals. You got another one that's seen in liver disease. If you look at figure 6-97, they're called leucine crystals. And I'll tell you how rare this crystal is. Look at figure 6-97 on page 137. Everybody with me? I will just about bet you that when you go to Google Images or Yahoo Images, you'll see the same exact picture. Okay?
Really?
That picture is everywhere. Okay?
That one
But it's
picture.
seen in liver disorders.
Very
I
rare.
think we're gonna have time to finish, but I need to go off and talk to you guys about something. The second
That's a good
test
deal.
is generally significantly lower in this class than the first test, all right?
Yeah.
I'm saying
a
that to
lot of
scare
stuff.
you, but what I normally do is I give everybody in the class a chance to raise their second test scores, grade by 10 points. It is not mandatory that you do this, and we use lab time to present them, but I give all the students in the class a chance to present a PowerPoint up here of nothing but urinary sediment, okay?
Right on.
I don't want a bibliography, I don't want a paper, I don't want anything.
It's a
I just want you to
presentation.
make a PowerPoint where you have all kinds of different pictures to show the class. It's mandatory that the class be here to watch your PowerPoint. That's the whole point of the exercise, is the more pictures you look at, the better. And what I normally do is, again, I give students, it's optional, you do not have to do it. But if you wanna put together a PowerPoint, and basically I'm expecting to have about probably 25 different pictures. And all I want you to do is say, this is what I found on my PowerPoint for what uric acid crystals look like. This is what I found for red blood cells. It's really not that hard to do, but it's a good learning exercise because the more you guys see them, okay, if Haley presents one, if Lisa presents one, if Ann presents one, you are all gonna have different pictures. See what I'm saying? And so you'll see different forms of it. I hope they don't all look alike, okay? But everybody does different research, and it's real easy. All you gotta do is type in urine sediment and then start saving them pictures, okay? Put it together in a little, even I can do that PowerPoint, all right? So, and then get up and do the class, and what I've normally done in past years is I add 10 points to the test. Okay? Anyway, it's optional. I've had students do it, I've had them not do it, but it's up to you, okay? But I will
That'll
give you a
be
chance to do that.
I'm gonna go home, make it tonight.
Okay, so if I asked you to give me 4 examples of abnormal crystals, leucine, tyrosine, those are seen in liver disorders.
Cysteine,
You got cysteine,
cholesterol.
cholesterol. Those are things that if you ever see those, you need to make sure that you report that out. All right. So ammonium biurate, what kind of urine specimen are we gonna see that in? Alkaline. A real old specimen. It's usually a contaminant of a specimen that's sit at room temperature. Now, I didn't go over all the crystals, guys. There's radiographic contrast crystals, there's what's called sulfa crystals. I just went over, I want you guys to be able to recognize the more common ones, okay? Even some of the ones I showed you are not common. Cholesterol crystals, for example, you will not see that very often. If you do, you're probably gonna take a picture of it. That's how uncommon it is to see it. Yeah, Patricia?
Yeah, when you said something about the cysteine crystals, you said 2 things. You said you can see it in people with cystinuria and something else.
I'm wanting to say, what I meant by cystinuria is, it's the ability, you'll see those, you remember us talking in chemistry about people that can't metabolize the amino acid cysteine, okay? And remember I said it gets into the tubules and it precipitates out into the urine, and you'll see those cysteine crystals. But you're not gonna see those every day at work. I mean, I'm just telling you, you're not gonna see them. I don't think I ever reported out a cysteine crystal. They're rare, okay? So if you start thinking you're seeing that twice a day or something, you might wanna get another tech to verify it.
You ever heard that leucines look like wagon wheels?
Yes.
They look like eyeballs.
Matter of fact, I normally say that every lecture. I can't believe I didn't say it, but yes. I did it in the intro, okay. Yeah, they do. They look like wagon wheels, but you're gonna be surprised how many times you see that one picture. Okay? They really use that picture over and over. And I challenge you guys to find some different looking pictures. If you can find them, bring them for your PowerPoint, okay? But I want you to cover everything. I don't want you to just go, well, here's 3 types of red blood cells. There's a green-aided one, here's a ghost cell, and here's a regular one. I want you to cover everything. Like, show me pictures of trash. We haven't even talked about that yet, but you know, you gotta make sure if you see a fiber or if you see a latex or any type of trash that you don't call that something. You see what I mean? Like a pollen grain or something like that. You can't call that a cast. And so it's real important that you read over the artifact section going on page 138 into 139. I can't tell you how many times I've seen, look at figure 6-TAC 102, those starch granules. Does everybody see that? Do you know what those come off of? Those come off your gloves you're wearing.
Really?
Okay? I've seen that all the time, and they usually have a dimple right in the
Starch
middle.
granules.
But see, you don't need to call that your acid
6-102.
Yeah, 6-TAC 102. Do you see those pictures? Like, you gotta be good enough at looking at stuff that you don't call those white blood cells. You see how
yeah.
you would really
I can see how
mess
they
up
could,
by doing that?
Yeah.
But I know the
It's
text
a lot
that I work
smaller
with,
and a
we
little
always,
in the middle
we
and
always say,
white
if you
blood
see a
cell.
dimple in it, it's trash.
Dimple.
That's what I did. I don't know what the others
Dimples.
Dimple.
say. Look at, let's see, figure 6-TAC 105. That's a fiber. Okay, fibers aren't in urine. that can be from anything. It could be a hair fiber. I mean, you know, guys, be realistic. You can have a piece of hair fall off while you're doing a microscopic and end up on your microscope slide. Don't call that hair a hyaline cast.
Right.
With me? Okay?
Yeah.
But you see, there is a squamous epithelial cell in that picture.
Yeah, I thought it. It's like the wagon wheel. Doesn't it?
Look on page 140. They even show you a picture of a diaper fiber. So a diaper. Page 140, figure 6, tag 107.
Really? It almost looks like
Yeah,
a granular
now that
cast.
vegetable fiber,
Yeah.
I'm not trying to confuse you, but that can be the real deal because vegetable fibers are in people that eat a lot of meat. You'll see those in stool specimens. You'll see like meat fibers and vegetable fibers. They look like willow leaves and stuff that if you're looking at stool under the microscope. So just kind of pretend you don't
It
see
does
that.
kind of look like a granular cast, doesn't it?
Yeah.
I would be
Yeah,
scared of
usually,
one.
but again, there's no exact science to me telling you exactly what a waxy cast will look like, and they'll all be a little bit different. You just have to be able to look at the characteristics to call them. All right, I didn't think we'd get through this, okay? I wish we had time, but, a lot of review questions on this chapter. Look at them, because I've got test questions that are straight off those review questions in the back, okay? Next Friday will be nothing but lab. We're not doing a lecture on anything. There'll be 3 hours of us in there